These are notes for 9.4b on local linearization. The idea of local linearization is what you see pictured here. From a distance, we can see that the Earth is round and has a curvature. Although when we're close on the Earth, we don't see that curvature at all. All we see is a flat road in front of us. And no matter where we are, we really only see this flat surface. When it comes to a graph, if I have a curve, let's just take something like this, and I draw a tangent line to my curve. So let's say somewhere right around here, we'll add this tangent line in. So there's a point where the tangent line and the function touch, they meet, they have the same value there. But what we want to look at is actually right along here on the x-axis. So the point where the function touches the x-axis is a value very close to my tangent line. So we're going to use the value of our tangent line to help approximate the value of our function, oftentimes because the tangent line is an easier function to work with. So this is actually a really easy idea, if that sounds at all complicated. So we're going to take a function, and this function is x minus 1 over x minus 3. And you're given a value here. It's an x value. We just don't want to call it x because we don't want you to plug it in here. But this value, what we'd like to do is find this point. So -1 something here. So we'll go ahead and plug the point into the function. So we want to know f of -1. So -1 minus 1 over -1 minus 3. We have -2 over -4, or 1/2. So here I have my point. So I'm on my way to writing the equation of the tangent line. So the next thing I need, of course, for any line is the slope of the line. And the slope of the line is the derivative. So we'll do the derivative of f here. So quotient rule tells us low d high minus high d low over the square of what's below. So x minus 3 squared. We distribute this negative. X minus x is 0, and -3 plus 1 is -2. We're left with x minus 3 squared in the denominator. So this is my slope function, and I'd like to evaluate it when my x value is -1. So again, I'm getting that from this number here. All right, so -2 over, that would give us -4 squared. So -2 over 16, or -1/8. All right, we're going to write the equation of our tangent line. So y minus 1/2 is equal to -1/8 of x minus -1, or x plus 1. Now, to make this the linearization function L of x is just y. So all we really need to do is take our 1/2 and add it over. So -1/8 of x plus 1 plus 1/2. So this is our linearization function. It's just our tangent line, and we got y by itself. So the idea is to now use the tangent line or the linearization function to approximate function f. So we want to use the tangent line. We want to use L of x to approximate f of negative 1.1. All right, so you can see if I had to plug negative 1.1 into function f, I'd have to do negative 1.1 minus 1, negative 1.1 minus 3, and then try to simplify that and see what I get. And so that sounds a little bit messy. So what I know from my graph here is that my function's value and my tangent line's value, they're very, very close. So the tangent line will just be easier to work with. So we take L of x, and we're just going to plug negative 1.1 into L. So negative 1/8 of negative 1.1 plus 1/2. All right, let's go back and fix that. Negative 1.1 plus 1 plus 1/2. So negative 1/8 of negative 0.1 plus 1/2. So my double negative becomes positive. We're left with 1/8 of 1/10. This is 1/8, and then 0.1 is 1/10. So this becomes 1 over 80 plus 1/2. So all we need is a common denominator of 80, which turns 1/2 into 40 over 80. And this is now 41 over 80. And this is my answer. And this is an approximate value of plugging negative 1.1 into function f. So if we want to know what that value actually is and compare it, we can do that. All right, so f of negative 1.1 is, where's our function here? Negative 1.1 minus 1 over negative 1.1 minus 3. So 0.512. If we go back up here to our linearization, 41 over 80. 40 over 80 is almost a half anyway. 41 over 80 is a little bit more. This is 0.5125. If you kept going with f, this follows with a 195 and so on. So you can see it's close enough to approximate without having to use a calculator or any other skills.